In this lesson, I just want to walk through a quick demo of the concepts we just discussed. I have two starter template applications open in Visual Studio, one for Web Forms and one for MVC. Right now we're looking at the MVC app. The main change I have made to these apps is to add a few application event handlers to the global.asax file. I have subscribed to the same events in both projects, which you can see if I click between them. One other adjustment I have made is to comment out all of the code that pulls in CSS and script files in both projects. We want to eliminate any unnecessary additional HTTP calls and just focus on the main URL requests to our framework homepages. All we want to do for both of these projects is run them and use the debugger to illustrate some of the concepts from the slides. I've subscribed to the post resolve request cache and map request handler events since it's between these two events that the HTTP handler for our app will be selected. I've also created handlers for the pre and post request handler execute methods. The MVC HTTP handler and our application code should execute between these methods, so I've added a breakpoint in our home controller of our MVC app. Let's run our application and just see what happens. So immediately we'll hit the post resolve request cache event, since this fires before the others we've subscribed to. If I open up our watch window, we can add an entry in here for the current HTTP context object. This context object just provides us with a lot of useful information about the state of our application. If we expand this object, you can see that the current handler is set to null. ASP.NET has not chosen a handler for this request yet. If we hit continue, you can see that the status will change, and we now have the MVC handler assigned for this request. Let's continue to the pre-request handler execute event, and you'll notice how we haven't hit any breakpoints in our application's code yet. If I continue one more time, that handler will begin to execute, and we'll jump over to our home controller. So now we're inside of the MVC framework, and all of our own logic will begin to execute. If we continue one more time, we'll jump back to the post-execute event, signaling that the HTTP handler is done handling the request. Let's pause here for a moment to look at one other bit of information. If we expand the application instance property of this object, we'll see another property called modules. If we expand the all keys property of this, you'll see that we actually have 17 HTTP modules registered with the application right now. As you read through some of these names, it's easy to guess at what services they're providing, such as session, Windows authentication, routing, and more. Let's stop our application and just jump over to our Web Forms sample app. We want to repeat this process just to compare and contrast the behavior of another framework. So let's just go ahead and run the project. Once again, we'll hit the post resolve request cache event. I'll again open up our watch window, and we can type out our HTTP context variable. After that's in place, if we expand it, you'll see that there is again no HTTP handler assigned. However, if I hit continue again this time, you'll see that we do not get the MVC handler, we actually get something called the transfer request handler. Now, this is kind of interesting because this is actually not the handler we might expect. Every ASPX page in Web Forms implements its own HTTP handler, so we should be looking for something with a similar name to our default.aspx page. Well, this handler is actually used by Web Forms to transfer requests with no URL extensions to the correct location. Since our homepage URL doesn't explicitly say what page to go to, it's going to use this handler to transfer it to the default.aspx page. This is a great example of how HTTP handlers can be used for other request handling purposes besides just entry points into full frameworks. I'm going to hit continue again until we land back in our first event. You can see that our handler is null again, so if we continue to the map handler event, now we'll see something that's more like what we would expect. This default.aspx handler is the one that's explicitly implemented by our default.aspx page. Let's hit continue a couple times so that it executes and we actually land inside of that page. Once we're there, we can right-click on the page class that it inherits from and select Go to Definition. Inside of this page class, you'll see that it actually implements the iHTTP handler interface directly. Hopefully you can see how this is different when compared to MVC. In MVC, we have one HTTP handler for the entire framework that dynamically selects a controller to handle the response. In Web Forms, each page directly implements this interface itself. This is part of why the Web Forms infrastructure is so directly tied to pages. So now we have a general understanding of the application lifecycle and how the frameworks respond to requests through HTTP handlers. In the next few lessons, let's discuss how Web Forms and MVC each process requests and generate a response through their respective life cycles and HTTP handlers.